All right, let's get into page 5, finish up the graphing, and then we got the regular graphing and we got absolute value on this page. All right, so problem number 15, we have, whoops, sorry about that. We have a cotangent graph, and we got to identify all the little bits, parts, and pieces. So here's the thing, with cotangent, as soon as you see amplitude, the answer is none. Because the graph goes up to infinity and down to negative infinity, there's no way to measure a maximum displacement or maximum distance. So that is taken care of. Period. Now we have a number here in front of x. So we're going to take the standard period for cotangent, which is pi, divide by that number in front of x. There's nothing to simplify, so pi over 2 it is. To find the phase shift, I'm going to take the whole expression inside the parentheses for the cotangent, set it equal to 0. So 2x minus pi over 4 equals to 0, solving for x. So I'm going to move the 2x, I'm going to leave the 2x alone. I'm going to move the pi over 4 to the other side. So 2x equals pi over 4, divide by 2, which is the same thing as multiplying by 1/2. So x is equal to pi over 8. So that makes a phase shift, right, pi over 8. And vertical shift, a lot of times we look at the end of the equation and say, oh, there's nothing sitting here. However, there is a value in front here. This 1 that's separated with the subtraction sign, the 1 is positive, so that means we're going to go up 1. Now, I want to pay attention to this minus 2 that's sitting in front of cotangent. So the minus in front of cotangent means I'm going to have a reflection, and the 2, that's not the amplitude. Remember, cotangent doesn't have amplitude, but that 2 means all the points are going to be stretched by 2. All right. So let's see if we can put this onto a graph. Now, cotangent, the normal asymptote location is on the y-axis and then go to the full period. So on the y-axis, I'm going to start here. Here's 0, 1, 2, 3, 4. That's going to be my pi over 2. I'm going to chop it in half, pi over 4, chop that in half, pi over 8, triplet. So 3 pi over 8. And what would normally happen now is I would have asymptotes on the y-axis. I don't know if you can see the little highlighter I just put in, and an asymptote at pi over 2. Now, these two asymptotes need to move, and the only reason they're going to move is because we have a phase shift right pi over 8. Now, pi over 8, pretty easy to see it. It is exactly one space. All right, if we look at the y-axis, nope, not the y-axis, the x-axis. Look at the x-axis here, right? From the from the origin, pi over 8 is 1 unit over, so one space. So I'm going to take these two asymptotes, I'm going to move them one space to the right. So that's going to create an asymptote here and an asymptote here. Okay. Now, normally, I'm going to use my little green x's here. Normally, cotangent is a decreasing function. So you'd start here right after the asymptote. You'd be at positive 1, 0, then negative 1. So x, x, and x. However, we have to do a few things here. We need to reflect it. We need to stretch it by 2, and then shift everything up 1. So let's go with the easy one. The one in the middle. Reflection doesn't count. Stretch by 2, no matter, there's nothing going to change. The up 1, yeah, that's going to move up 1 space. All right, so let me kind of zoom in here. So now this point at positive 1 is going to reflect to negative 1, stretch further away from the x-axis, but then go up 1. All right, so we're sitting here. And then this point, we're going to reflect over the x-axis, stretch it by, in this case, instead of being at 1, it's going to go to 2, all right, and move it up 1. Now, what you can look at is from the middle to the high point here, there's 2 spaces. From the middle to the low point, 2 spaces. That's kind of a little hint to make sure that you're getting everything in the right place. Draw in the actual curves. I know as we stretch tangent and cotangent, the curves become a little bit more difficult to draw, but please do make sure that you have curvature in the middle part here and you're curving towards the asymptote, but please do not cross them. All right, so problem number 15 is done, and now we've got 16 and 17, which are the absolute value functions. So absolute value, we're going to start by graphing the regular equation, the regular function. So what I'm going to do here is I am going to list out what I normally would. So period, amplitude, phase shift, and vertical shift. However, I'm going to make a note that this is for the non-absolute value equation. So I'm going to pretend that the absolute values just don't exist. Just don't exist at all. So period here, we've got no number attached to x as far as a multiplier. So that's going to give me a period of 2 pi. My amplitude, the 2 in front, gives me an amplitude of 2. Phase shift, I'm going to take x plus pi, set it equal to 0, which makes x equal to negative pi. So that's going to be left pi units. And then vertical shift, I've got this point right here, which would be down 1. No reflection other than absolute value. We're going to have to deal with that. So what I'm going to do now is I am going to graph all of this, and then I'll deal with the absolute value. Okay. So coming down here, all right, yep. I've got to label the x-axis. So starting at the origin, 1, 2, 3, 4, that is 2 pi, pi over 2, and of course 3 pi over 2. 1, 2, 2 here, and negative 2 here. So this is where we're going to start, and I'm just going to do little X marks the spots for the sine curve that I would have originally. Now this one I'm going to leave just the, I will deal the phase shift and the vertical shift in a minute. So standard sine starts at the midline, up to the maximum, midline, minimum, midline. Okay. Now all of these points, all these little purple X's are going to move. Now how are they going to move? Well, I need to move every one of them down 1 and left pi. All right, well, let's see. Pi is 2 units from the origin, so that's going to be 2 spaces. Okay, so every one of my little x's is going to move 2 spaces to the left and 1 space down. Okay, so 2 spaces left, 1 space down, 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 and down. Okay, so this is if absolute value wasn't even a part of this problem. This is where all my points would be. Now what I'm going to do is I'm going to come in here with a highlighter, and I am going to try, if I can get it, to do a, because I'm fighting with my iPad here. Let's see if it wins or I win. There it goes. I'm going to put in a dotted, there we go. I'm going to curve through with a dotted line, dotted curve. All right, so All right, so this is what the curve would look like. No absolute value at all. However, that's not what I have. What I have is an absolute value graph. So what I'm going to do is I am going to take all of these values that are below the x-axis. So all of these negative values, I need to reflect them up. Because if the value is -1, the absolute value of that's going to be +1. If the value is -3, the absolute value of that's going to be +3. So all of the stuff underneath the x-axis needs to reflect up. And all the stuff that's above the x-axis just stays there. So there's a point, there's a point. So this point's going to pop up. This point is going to pop all the way up to +3. And then this point's going to pop up to 1. Okay. The dotted curve that I already have above the x-axis, I'm just going to copy right over it. Now, this part of the curve, I need to mirror up. So this point down here where you just touched the x-axis, bounce right off of it, up to this point. That was a horrible, hold on. There's a little curve there. Slightly better. All right, same thing on this side. This whole curvature needs to be reflected now over the x-axis. So point up, 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 curve, 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 and then curve on down. Now, one thing I want you to be aware of is I've talked repeatedly about these being curves, and I've said that when you hit these points, right, make sure that you're doing curves and curves. The one time you're going to have some points are when you're literally bouncing off the x-axis for the absolute value. All right, there's no curve here because it's just you're reflecting this portion of the graph up. So this blue curve, okay, is the absolute value curve. The other parts of the graph, the little X's, the little dotted line here, the green dots, this is all just to help us get to this point, okay? All right, so problem number 16 is done. Let's finish up with number 17, and I'm going to do the same thing, okay? I'm going to get information based off the cosine curve, all right, that all I'm going to do is ignore the fact that I have an absolute value. So first thing I notice I've got all right, let's see what we normally find. So amplitude, period, phase shift, vertical shift. And again, all of this is from the non-absolute value function or value equation. So not asymptote, A stands for amplitude. So amplitude is 3. Period is going to be 2 pi. Phase shift, x minus pi over 2 equal to 0, which makes x equal to pi over 2. So that's going to be right, because the pi over 2 is positive, right pi over 2. And then vertical shift, we're going to go up 2. There's one other thing I need to pay attention to. There's a negative here, which is a reflection. All right, let's see if we can put this on the graph, okay? So on the graph, go to my x-axis. So there's the origin, 1, 2, 3, 4. This was a period of 2 pi. So that's going to be pi, pi over 2, and 3 pi over 2. And then we label the y-axis here. We had an amplitude, I think it was, what was it, 3? Yeah, amplitude was 3. Okay, so 1, 2, 3. 1, 2, negative 3. Okay, so I'm going to graph this using the reflection, the amplitude, and the period of 2 pi. So this is going to be a reflected cosine curve. So that would start down low, hit the midline, up to the maximum, midline, and then back to the minimum. None of these points are going to stay here, though, because every one of them needs to deal with the phase shift and the vertical shift before you even get to absolute value. So phase shift was right pi over 2, which is 1 space. So let me make a little note here. This is going to be right 1 space. And then I need to go right 1 up 2. Okay, so every one of these points, I'm going to go right 1 up 2, right 1 up 2, right 1 up 2, 1 up 2, right 1 up 2. Okay, so I've got all my points in the right places. I'm going to go back to my highlighter here. And what I'm going to do is I'm going to graph what I've got here. So there's that part. Here's this, curving on down. Okay. Now, all of this part of the curve that is above the x-axis is not going to change. So all I'm going to do is go right on over it. So where I start from the x-axis, go right through all these points. There's no change here, here, and here. However, this part that's below the x-axis, we're going to bounce up or reflect up. So at -1, we're going to reflect up to +1. And take this part of the curve and just reflect it so it connects. Let's try that a little bit better. Here's a little curve there. And then same thing over here. -1, I'm going to reflect it up to +1 for absolute value. And then, wow, I can't draw that. So let's try that again. Slightly better. Okay. So the dark blue solid curve here is the absolute value part. Now I realize I need to change a couple of things or add a couple of things to this graph because I've changed my maximums and I've also shifted, so I need to also label the x-axis a little bit better. So maximum point here is now 5. I will deal with the rest of the y-axis. If you wanted to label it, you could. It's fine if you don't. As long as you hit the maximum and the minimum value, I'm good. This part of the x-axis does need to be labeled, though. So let's see, pi over 2, 2 over 2, 3 over 2, 4 over 2. So this would be 5 pi over 2. And I'm kind of feeling like that graph is done, but I want to go back to number 16 really quickly and do the exact same thing I forgot to do on the other graph. Or I forgot to do it on this graph. I did on the last one. I did not label my x-axis, nor did I change the labels on my y-axis. So this would be positive 3 for now my maximum. And then these values I'm going to mirror over here. So negative pi over 2 and negative pi. So please do make sure that you are labeling both the x and y axis, especially if you have to do any kind of phase or vertical shift. Make sure that you're going through and labeling the appropriate values. So those two graphs take care of 16 and 17. That takes care of page 5, and I will do one last video. I believe there's just a page 6 left. Let me know if you guys have any questions or concerns.